So number 1 is not a perfect square, but you could use the perfect square 9 and 5. 9's the perfect squares. That comes out to be 3. So the final answer is 3 root 5. Okay. On number 2, I can do factors 4 times 3. 4 is the perfect square. You bring that out. That becomes a 2. So the final answer is 2 root 3. I mean number 3, sorry. I'm only doing the odds.
What are you doing?
Number 5. What perfect square factor goes into 200? Anybody know the perfect square factor that goes into 200? 100 times 2. There we go. The square root of 100 is 10. So this becomes 10 root 2. Now when you get to 7, you have a coefficient on the outside that needs to stay outside. And then you can factor. I can factor the 20 with 4 times 5. 4 is the perfect square. It will come out as 2 with the 2 on the outside. So what we're really doing here is saying 2 times 2 in front of the radical, 5 stays inside. So this is simplified as 4 root 5. Now on number 9, we're dividing by radical. We cannot keep it like that. We have to rationalize it. Which means we multiply the top, the numerator, and the denominator by that radical in the denominator. We're going to just multiply straight across. So this becomes root 5 on top and just 5 at the bottom. For 11, because the radical is over the whole fraction, I'm going to break it up and put the radical on the numerator and on the denominator. Root 36 is a perfect square. That just becomes 6. And then I have radical 5 in the denominator. I cannot leave it like that. This is now when I rationalize it. So I'm multiplying the top and the bottom by the root 5. When I do that, this gets simplified as 6 root 5 on the top and just 5 at the bottom. I can't do anything else because 5 cannot go into 6. So that is the simplified answer. Now, on 13, simplify each part first. Can I simplify root 45? What are the factors? So I keep the 2 as the coefficient and put 4 times 9 inside. Now, root 9, what is that? I'm sorry. Nine times 5. Okay, what is root 9? Simplify to just 3. So this is my perfect square that comes out. It comes out to this 2 here that we already have. So really what I'm saying is 3 times 2, root 5 on the top and 3 at the bottom. I'm going to multiply out mates because those can get multiplied together. So this becomes 6 root 5 over 3. And then we have to be able to look at these two numbers that are outside and reduce them. What is 6 over 3 reduced to? 2. So this becomes 2 root 5 as the final answer. On 15, we need to rationalize the denominator. So we're multiplying by root 6 to the top and bottom. When you do that, this becomes 2 root 6 over 6. And then again, if you look at the 2 over 6, that can be reduced. What can we reduce that to? 1 over 3. 1 over 3 root 6 is what I can write, or I can write root 6 over 3. So after being able to rationalize and simplify, you will be asked to multiply. Remember, inmates and outmates don't mix. Our outmates here are 4 and 3, so that gets multiplied together outside of the radical. Our inmates are 10 and 6, so that gets multiplied inside the radical. This gets simplified as 12 root 60. But then the 60 can be simplified. There is a perfect square that goes into 60. What perfect square goes into 60? 4 times 15. 4 is the perfect square. So when I take this 4 out, take the square root of 4, it's 2. So this gets simplified as 24 on the outside of the radical, root 15. All right, on the next page, we have some more simplifying, but with division. So I would simplify each radicand first. So like, for example, root 27 is 9 and 3. 9 is the perfect square. Root 8, I can simplify that, with 4 times 2. 4 is a perfect square. When I take this perfect square out, I'm left on top 3 root 3. When I take this perfect square out, I'm left with 2 times that 3, root 2. So really what I have is 3 root 3 over 6 root 2. All right, now I cannot leave it like that because we have a radical in the denominator right here. So to get rid of that, I'm multiplying by root 2 to the top and the bottom. When I do that, I now get 3 root 6 in the numerator. And then I'm doing 6 times this 2, which is 12, in my denominator. If I look at my outmates, that can be reduced. 3 over 12 can be reduced to 1 over 4. So I can say 1 over 4 root 6, or I can write it as root 6 over 4. So 21 is like 19 in the fact that I'm going to simplify the root 72 first. And it has a coefficient. So I'm going to keep the coefficient on the outside. 72, I know 36 times 2 will give me the 72. And I'm going to keep the 10 root 3 in the denominator. The 36 is the perfect square that comes out and gets multiplied to that coefficient. So really this is 36 root 2 over 10 root 3. I cannot keep the root 3 in the denominator, so I'm going to rationalize that. So I'm going to multiply the numerator and the denominator, by root 3. By doing that, that's going to leave me with 36 root 6, because 2 times 3 gives me 6, over 10 times 3 is 30. Then I look at my outmates, the numbers on the outside, which is 36 and 30, and I try to reduce it. 36 over 30 can be reduced to 6/5. So I have 6 over 5 root 6, or I can write it as 6 root 6 over 5.
Good morning. Do you need face masks, right?
Pyth face mask. I think I'm have two here. Thank you. Okay.
Wipes, alcohol wipes.
Oh no, I got those. Thank you. Okay, so now we're going to use Pythagorean Theorem on this next section. Just remember, your Pythagorean Theorem is only for right triangles. It's used only with right triangles. Okay. The theorem states that the sum of the leg squared, which is our a squared, plus b squared equals c squared. Your parts in the Pythagorean theorem, a and b, are interchangeable, so these are really just your leg squares equals to your hypotenuse squared. Okay, so they want us to use exact values right here, guys. It says solve for the missing side or sides, use exact values. That means that has to be a simplified radical. So I'm going to focus on odd problems. Your hypotenuse or the leg or the hypotenuse or your C is always opposite the right angle. So to set this up, we should be starting off with x squared plus 3 squared equals 18 squared. You will need a calculator because you're going to have to square numbers and add and subtract and then simplify. This becomes x squared plus 9 equals 324. To solve for x, you're going to have to subtract the 9 to isolate the x squared term. So x squared equals 315. The last thing you'll do to get your actual x value is take the square root on both sides. The perfect square that goes into 315 is 9. 9 times 35 gives me 315. So that means the x equals, we take out this perfect square, 3 root 35. That's the exact value. Now, you do need to remember, that's why a calculator is important on these, is what happens when you square a radical. If I'm setting up number 25 using Pythagorean theorem, I know that it's missing the box here, but if I'm using a squared plus b squared equals c squared, this would be m squared plus 15 squared equals, in parentheses, 3 root 34 squared. Fifteen squared is 225. 3 root 34. Remember to use your parentheses when you're doing that. Oops, sorry. Delete that. Second x squared, there we go, 34. Arrow to the right, close your parentheses, and then square it. This actually comes out to be 306. Make sure you use parentheses or you're going to get the wrong number. The number should always be bigger than the leg square. if it's the hypotenuse. So this is 306. Now to find our m, we're going to subtract the 225 from both sides to isolate the m squared term. So we get m squared equals, what was that, 81. And the last thing we have to do is take the square root. Yep, this one is a whole number answer of 9. Now on 27, the key thing you have to remember is what equilateral means. That means all sides are congruent. Okay, so that means if I see 24, it would be here, and it would be on this whole length here as well. But since x is the height in the equilateral triangle, it's also part of just this right triangle right here. The height bisects this side, so this would be 12. If I cut 24 in half, that becomes 12. So now I can do the Pythagorean Theorem with this triangle. I know it's not to scale, but this is 12, x, and 24. So if I'm using Pythagorean Theorem here, this would be x squared plus 12 squared equals 24 squared. That becomes x squared plus 144 equals 576. Subtract the 144 from both sides. We get x squared equals 432. Then we're going to take the square root. 432 is not a perfect square, but it does have the perfect square factors of 144 times 3. So 144 is the perfect square. When you take that out, that gives you 12. So our x is 12 root 3. Alright, besides just doing Pythagorean theorem off of different right triangles with different side measures, you will have a word problem. Go to the next page. Anyone still need the other page? Because we're using Pythagorean theorem with word problems, that means each problem should have some type of right triangle in it. So right here is your hint. It says draw and label a picture. That picture should always have a right triangle. The orientation could be different, but it should always be a right triangle. So I'm just going to focus on the pictures here and then actually do 29. If it says Westfall is 7 miles south, south would be this way. So that would be our 7 here. And then it says 13 miles west. West is to the left. I know it's not to scale, but those are our 2 lakes. They want us to find the distance between the 2 cities. So there's the missing side, the x. So on 29, we're dealing with the right triangle every time to use Pythagorean theorem. The rope from the top of the mast on the sailboat is attached to a point 19 feet from the mast. If the rope is 20 feet long, how tall is the mast? So this is what we're trying to find. How tall? Well, the height is vertical, so that's what I'm trying to find. I know the rope is 28 feet long. That would be the hypotenuse. And it's 19 feet from. That would be the horizontal distance. So now we're doing x squared plus 19 squared equals 28 squared. Now we're going straight into Pythagorean theorem. This would be x squared plus 361 equals 784. Then we need to subtract the 361 to isolate the x squared term. We get x squared equals 423. Now I need to take the square root. That's the last thing on both sides. This does have a perfect square factor of 9 times 47. The 9 would come out. So x equals 3 root 47. Alright, on this section, using Pythagorean Converse, there's a couple things you have to check. The first thing, I'm going to write it right here. First, you need to check that the three sides make a triangle. The way that we do that is you check A plus B, it has to be greater than C. Then after this, if that is yes, so second, if yes, it's a triangle. Then you have to use converse. You will need to memorize each one. For example, for acute, you're supposed to know that c squared has to be less than a squared plus b squared. For right, if it's a right triangle, that's when c squared is equal to a squared plus b squared. And for an obtuse triangle, that's when c squared is greater than a squared plus b squared. So make sure you know what creates each type. This is acute. Equal is right. Greater than is obtuse. So first, you check the sides. The biggest side is 19. I'm comparing it to the other two. 9 plus 15. Is it greater than 19? Yes, this is 24. 24 is greater than 19. So yes, it's a triangle. But then, now you take the largest side, which is the 19. You square it, and you compare it to the sum of the other two sides squared. Alright, so 19 squared, that gives you 361. 9 squared is 81. 15 squared is 225. So basically, I'm comparing 361 to, what is it? 306. When you add 81 and 225? Yes or no? You're with me? Yeah, because this is greater than here, this answer is obtuse. So what do we do first on 33? So we need to add 8 and 12. Is it bigger than 14? Yes. Now what do we do? Now where do you start? Yeah, square the 14. That's the largest side. 14 squared. Compare it to, yeah, 8 squared plus the 12 squared. 14 squared, that's 196. Dang it, why keep doing that? This is 64 and 144. What's 64 and 144? 208, yep. So 196 compared to 208 is less than, which means this would be an acute triangle. All right, and then the last thing, the last skill will be using your distance and midpoint formula. Distance is when you subtract the two x values, so x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. You don't have to memorize the formula, it is on the formula chart, but you do have to apply it. So 34 is asking you to use the distance formula. Midpoint formula, capital M for midpoint, this is when you add your x values, so x1 plus x2, then divided by 2. And you add your y values. So 35 is asking us to find the midpoint, find BC if B is that. So it's actually, this one should have been find the midpoint, sorry, because it's in this column. So you have to remember this is x1 and y1. The next coordinate is your x2, y2. So if I'm going to find the midpoint, I'm adding my x's, which is 8 plus a negative 4 over 2. And then I'm adding my y's, which is a negative 7 plus a negative 2 over 2, and simplifying them. 8 plus a negative 4 is just 4 over 2. This would be negative 7 plus a negative 2. That gives me negative 9 over 2. This can equal 2 comma negative 4.5. Now, if I ask you to graph or give you the graph and find the segment, they want you to find PQ, I would make a right triangle and use Pythagorean Theorem. To make the right triangle, you need to draw your vertical leg and your horizontal leg and count to find its length. This vertical leg is 1, 2, 3 units. This horizontal leg is 1, 2, 3, 4, 5, 6, 7 units. That's a 7. So now all I have to do is do 3 squared plus 7 squared equals c squared. The c is the length of PQ because the c is over here. All right, so we got 9 plus 49 equals c squared, which is 58, equals c squared. Take the square roots of both sides. This does not have a perfect square to go in it. No, because 2, that's 29, 29 is prime. So our final answer is just the square root of 58 equals c. If you can't simplify it, you leave it as that radical. Now, 39 says if M is the midpoint of segment AB and M has this coordinate and A has the following coordinate, they find the other endpoint. To do this, we start off with our segment AB with M as its midpoint. Remember, if it's a midpoint, then they're equal distance between them. We know the coordinate of A was given to us. Sorry, I probably should do that color. or in the coordinate of m. I'll put underneath here was a -4, comma -5. And a here was a -2, comma -9. So now I'm looking for the distance between those coordinates, how it changed. It went from a -2 to a -4. How did that value change? -2. So we're going to repeat that to get the b. We're going to -2 again. So this x coordinate is going to have to be what for b? Oh, I'm starting at -6, or -6. If I'm starting at -4 and I subtract 2, I get -6. All right, then we're doing the same thing with the y coordinates. It goes from a -9 to a -5. How did those coordinates change? We added 4. So now we're going to add a 4 again. If I'm at a -5 and I add 4, what do I end up with? -1. And there is our coordinates. -6, comma, -1. All right, you are going to complete the evens. This is due tomorrow. Test is tomorrow. Yeah, if it's turning today, yeah.